we'll start with circles now. There are relatively few concepts here. So we start a discussion on circles with some terminology. First of all, note that what is a circle? It is the locus of a point which is fixed distance away from another point. What that means is, say, I have a point over here, O, and locus of a point means the set which satisfies, the set of points which satisfies this condition. So all the points in that. Let's say I say that this point should be 5 centimeters away from point O. So then this point will satisfy this condition. Then there'll be another point here which will satisfy this condition. Another point here will also satisfy this condition. All these points will be 5 centimeters away from O. Then there'll be another point over here and another point over here and another point over here. All these points will make a circle. So basically, when we say what is a circle, it is the locus of all the points, or locus of a point that is a fixed distance away from another point, from this point O. Right? So when we'll join them, we'll get we should get a circle. We haven't really got it, but yeah, that's what it is. Right? All right. So then this is a circle, and we know that a line passing through the center is called a diameter. So here is the diameter of the circle. It divides the circle into 2 equal parts, right? They are the 2 semicircles. They are the 2 halves. The angle over here is 180 degrees, right? We know that the entire central angle, the angle around a point, the entire central angle is 360 degrees. So since the diameter divides it into 2 equal parts, then each part has an angle of 180 degrees. So this is also our 180 degrees. All right. Now, a line segment AB is called a chord of a circle. This is the chord. It joins 2 points which are on the circle. But not the 2 points which are diametrically opposite. That is, this is called a diameter when it passes through the center, right? So a chord that passes through the center is called the diameter, but a chord could join any 2 points. This is also a chord. This is also a chord, right? These are all chords. Now, what does a chord do? So let's look at this diagram now. Here our AB is a chord, right? And it divides the circle. It divides the circumference of the circle into 2 parts. So this smaller part, because AB does not pass through the center, so it does not divide the circumference into 2 equal parts. This smaller part, the orange one, which is signified by this orange line, it is called the minor arc, which means it's the smaller arc. And the rest of the circle, the rest of the circumference of the circle shown by this black line is called the major arc. So the chord divides the circle into 2 parts, the circumference of the circle into 2 parts. One is called the minor arc and the smaller one, and the bigger one is called the major arc. Normally, when we say arc AB, what we mean is the minor arc, unless we specify that we're talking about ADB. So when I talk about arc AB, it will normally mean it is the arc ACB, the minor arc, the smaller one. All right. So now, so if, let's say, what is the length of this arc ACB? That depends on the angle that it subtends at the center. So as we discussed that this entire central angle is 360 degrees. So let's say it subtends an angle theta at the center, the arc AB, right? So if we join A and B to O, then the angle formed is theta at the center. Then the length of this arc AB is theta upon 360. It is a fraction of the entire circumference. What fraction is it? It is theta upon 360 of the entire circumference. Now, what is the circumference of a circle? We know the circumference of a circle is given by 2 pi r. And what is the area of a circle? That is given by pi r square, right? So basically, R, the radius of the circle, it defines a circle uniquely. And we saw why. Because circle is nothing but the locus of a point at a fixed distance R away from the center, which is just another point. All right. So then, so we come back here. So we say that this arc ACB, it subtends the angle theta at the center, and that is why the length of the arc AB, this curved part, the minor arc, is theta upon 360 into 2 pi r. 2 pi r is the entire circumference, and this is a fraction of that circumference. Then what will be the length of the major arc, ADB? So then I can say the length of ADB will be just 2 pi r minus theta upon 360 into 2 pi r, right? Or I know that this entire angle is what? 360 minus theta. So I can also say that the length of arc ADB will be equal to 360 minus theta upon 360. This is the angle into 2 pi r. Look, of course, you see that this expression, this one, is exactly the same as this expression, because if I open this up, I'll again get 1 minus theta upon 360 into 2 pi r, which is nothing but 2 pi r minus theta upon 360 into 2 pi r. We get this expression back again, right? All right. Then, okay, what is the area? The area that is covered by this AB sector. Now, this sector, A, O, B, and C, this entire sector, the one which is shaded in blue, this is called a sector. And what will be the area of this sector? Now, again, this part is a fraction of the entire area of the circle. I know that the central angle of a circle is 360 degrees, whereas the angle of this sector is nothing but theta. So then again, the area of this sector, let's say area of sector OACBO. So you know exactly what we're talking about, the entire blue shaded area. This will be equal to theta upon 360. That is, it is again a fraction of the entire area of the circle. And what fraction it is? It is theta upon 360th of the entire area of the circle. And the area of the circle we know is pi r squared. So then area of this sector is OACBO is going to be theta upon 360 into pi r square, the entire blue shaded area. Now this part, the part that I'm shading right now, this is called a segment. So AB divides the circle into two segments. This is called the minor segment, the smaller part. This is our minor segment. And the other part, the ADB. So let's put it in another color. Say here, this entire thing is called the major segment. This is our major segment. So we could be asked about the area of the minor segment also. So what is the area of just this? We know what is the area of the sector. The sector is that blue shaded area. But if we need the area of only the minor segment, what will we do? We say area of minor segment will be equal to the area of the sector, which we found using this formula above, minus the area of the triangle, which triangle AOB. So we'll find the area of this triangle. Let me show you with green lines now here. This is the area of the triangle. From the area of the sector, we'll remove this particular area, and that is what is going to give us the area of the segment ACB. How do we find the area of this triangle? Well, we'll be given enough information for that. One thing that we should keep in mind is that if we drop a perpendicular from the center O onto the chord, then it splits the chord into two equal parts. So if I draw a perpendicular, let's say AP, OP, then the P splits the chord AB into two equal parts such that here AP is equal to PB. Yep. And we'll be given enough data to find the area of this triangle as well in case we are asked the area of the segment.